I'm remaking this video because I feel as if I didn't really communicate this guy's name properly, so I actually wrote it out now. Frank Nadarzik, and you can get his work on Speed Peer. Frank Nadarzik. Okay, he's the guy who did the math and made this discovery that does away with Planck's constant. In other words, Planck's constant has been derived, which is something that Planck thought would happen eventually someday, or always hoped would happen. Never did in his day. I guess it's almost maybe 100 years later. But also what has been derived is the permittivity of free space constant, the number that Richard Feynman's always talking about, that, you know, scientists have always, you know, wondered if somebody's going to solve, you know, the why this number, 1 over 137,0011, whatever it is. So that's been derived now as well, all on the same principle. And basically what has been discovered is that the electron jump, which was thought to be quantum in the sense that it was a probability factor, and of course Planck's constant. As a Planck's constant was just automatically, you know, had to be multiplied. So what happens is the photon comes in and enters the electron, and it automatically assumes the speed of the electron's phononic vibration. So the body of the electron is vibrating at a certain speed, and the photon assumes that speed, and that does something to the quantum state of the electron, which enables it to take on superfluid properties, and it actually moves to the next orbital. So it doesn't actually take the quantum leap, but there's actually a real trajectory. It takes an actual trajectory through space and time, and so that mystery of the electron has been derived. To me, that's a major, I would think, a major you know, paradigm shift in terms of the interpretation. It doesn't change too much in terms of the predictive power, but it certainly changes the interpretation. I mean, it vindicates Max Planck, and it vindicates Albert Einstein too. It's really Max Planck always thought that there has to be some way to derive that. Now, it wasn't until the Copenhagen guys came in and sort of did away with thinking about physical reality behind some of these phenomena. And so I believe that the probability wave is going to be the next thing that's going to go. And the reason I say that is because this quantum leap, you know, was supposed to be part of that whole train of thought that the electron sort of assumed a non-real position as it was between orbitals. So this takes away that non-reality of the Copenhagen interpretation. And I get this idea for an experiment. I'm surprised it hasn't been done yet, but maybe not. Maybe nobody's thought of it. But if you go to I guess a university level might have the facilities. What you need is the double slit experiment with electrons, one at a time. Okay, so we're talking about, I guess the more sophisticated equipment than just your little pocket laser. And I guess they have they'd have something like that at one of the universities. And so what we're going to do is we'll have your screen and then your collector in the back, and you're going to be shooting these one at a time. And of course the expectation is the development of the interference pattern on the backdrop. But what I'm suggesting is we're going to take a magnet and after you shoot one electron, you swing the magnet over to the one side. You don't swing it, just swing it to the other side and stop it. And then you shoot another electron, and then you let the magnet swing back through the field. And after each electron, every time an electron fires, the magnet swings. And the purpose of this is that is to determine whether or not the field is contributing to the property of the interference pattern. So if you have the one electron going through, and that's what's happening, one electron is contributing to an interference pattern that that would require, in some sense, it's interfering with itself at one level. So my thinking is that you fire an electron, and it does something to the field of space between the plate and the collector and the screen that can be disturbed with the magnet. Okay, now it's very easy to see. Well, it's either going to happen or not. I'm kind of predicting that if, well, let's put it this way: if what I'm thinking is true, that as each electron goes through, it contributes to the field, so that when the next electron comes through, it's the field that sends it off into an interference pattern. Okay, I guess you can see where that's a little bit different than anything that I've heard of has ever been done. Now maybe somebody's tried it, and it's not there was no results. It didn't change. It didn't change. You still got the interference pattern, because what I predict is that the magnet would disrupt the field, and even though you're not observing which slit the electron went through, okay, you're not making that observation, but it still collapses the wave, so to speak, and you don't get the interference pattern. So anyways, that's my proposal for an interesting experiment, and my remake on the death of the probability wave. So any thoughts or questions, I'd appreciate it.